Hi everyone, for today's lesson we are going to learn about reflections. That is our second rigid transformation. Our I can statements for today is for you to be able to say, I can reflect points over a vertical line and a horizontal line. And I can reflect points over the lines y equals x and y equals negative x. Before we get started for today, I need you to have the following items. First, you will need something to write with. You will need a glue stick or something or Scotch tape. You'll need some scissors, colors like highlighters, and you will need to print out the Unit 2 Day 2 cutouts. The cutouts that we are going to be working with first are going to be the properties of reflection lines. There is a smaller rectangle that goes along with these properties. We're going to be working with the example to use the figure at the right. You'll see like a graph inside. This is what we will be working with second. And then finally, there are two identical rectangles that we will be working with third. So those are the cutouts that you will need for today's lesson. Here we go. So our I can statement is I can reflect over a vertical line and a horizontal line. Let's make sure that we understand what vertical lines are and what horizontal lines are. A vertical line looks like this. It has a line that's going up and down. And it's part of the equation, x is equal to a number. So if you see where x is equal to a number, that's called a vertical line. You will see an equation of x equals a number. Next, we have a horizontal line. A horizontal line goes to the left and goes to the right. It is y equals a number. So you're going to see in a horizontal line going from left to right, and you'll see an equation of y equals a number. I call this Vux and Hoy, a vertical line, undefined slope, x equals a number. Horizontal line, 0 is the slope, y equals a number. So we call that Vux and Hoy. Vertical line, undefined slope, x equals a number. Hoy is horizontal line, 0 is the slope, y equals a number. This is a box I need you to know and study. I'm sure you learned this before when you were in Algebra 1, but I need you to know it and be able to use it in this class. The second type that we had in our I can statement is to be able to reflect over the lines y equals x and y equals negative x. As a reminder, I'm going to draw what these lines look like. These lines are linear functions. They both have a y-intercept at 0, 0, and then their slope is located at rise 1, run 1. This is a diagonal line. The graph for y is equal to negative x looks like this. It has a y-intercept located at 0, 0, but its slope is going down 1 to the right 1. It is also a diagonal line and a line that we will be working with in today's lesson. Once again, these are diagonal lines. ahead and talk about what a reflection is. A reflection is a very special type of transformation. It's just like it sounds. Think about looking into a mirror. You're going to see yourself. This is where we are going to be reflecting over a line, and the line is like our mirror. On the other side, a figure should see itself. A reflection is a transformation that uses a line like a mirror to reflect a figure. So just like it sounds, it is a transformation that uses a line like a mirror to reflect a figure on the other side. That mirror line is called the line of reflection. So the mirror line that we were talking about, those mirror lines are going to be either vertical, horizontal, or diagonals. They are called the line of reflection. Reflections have certain properties. So if you wouldn't mind taking out the properties of reflection lines, we are going to create the same type of cutout that we have all year long. What I would like you to please do is please go ahead and paste this box into the center of the other box. And then I would like you to please go ahead and cut. The first property that we are going to talk about is that if a point is not on a reflection line, we're going to call that line M. Then line M is a perpendicular bisector of segment P prime. That's a lot right there. So what I would like to do is I want you guys to please go ahead and draw a line. We're going to call this line M. I would like you to please go ahead and put a point P on one side of that reflection, of that one side of the line. If we were to reflect this point on the other side, it has to be a perpendicular bisector. That means that when we are counting across this line, it has to get ourselves a reflection point on the other side to get to P prime, to reflect it on the other side. Line M is the perpendicular bisector. So the thing that I need you guys to know is that perpendicular means that it intersects at a right angle. So we have right angles on each side. The other word that we have here is bisector. And if you think of a bisector, a bisect means to cut in half. So a bisector cuts a segment in half. So if we were to look at this segment that is between point P and point P prime, line M is cutting directly through it, right at its midpoint. And so that's equidistant away from our reflection line. The second property that we have is that if point P is on the line of reflection, so I'm going to draw line M again, and I'm going to put point P on it. Then point P has to equal P prime. How do you reflect something when it's on the mirror? Well, that means that the point, they are the same exact point, and their distance away from the line of reflection is going to be the same. So if it's on the line, they are the same point. There's going to be no transformation that takes place. It remains the same point. All right, these are properties that I need you guys to be aware of, especially as you are completing your homework and drawing reflection lines and drawing figures. If you wouldn't mind going ahead and pasting this into any place on here is perfectly fine. And we're going to call these the properties of reflection lines. So all of this is the properties of reflection lines. I have to go to the next page. All right, the next thing I want you guys to have out is our quick example. If you wouldn't mind gluing this example at the top, that would be very helpful. And it says in this example, use the figure at the right to answer the following questions. If A prime is a reflection point of point A, where would the line of reflection be? Now this is where we're going to be using those properties. Remember that if we were to draw a segment in between these 2 points, the line of reflection has to be the halfway point going through the midpoint of these 2 segments. So where would it be located? It would have to be located halfway between point A and A prime. So what is the equation for that line of reflection? All right, let's go inside and see what we can come up with. So if I were to count the distance between A and A prime, it would be 1, 2, 3, 4, 5, 6 units. So half of 6 is 3 units. So I'm going to count 3 units going from A prime to A. 1, 2, 3. And my reflection line is going to be a vertical dash line. It's always dashed because it's just a guideline. We always write them as dashed lines. So I'm going to write down that they are always dashed. And so because in between here is 6 units, we want 3 units on each side, our reflection line ends up being vertical this time. And so because it is a vertical line that crosses when x is equal to 1, we're going to say this equation is x equals 1. And that's because this is a vertical line with undefined slope. And x equals a number has to come with that. There is your VUX, VUX. Vertical line, undefined slope, x equals a number. Remember that horizontal was horizontal line. Zero is equal to the slope. And y equals a number. There is your H-O-Y, HOY. Vertical lines versus horizontal lines. So in this problem, it's a vertical line, and that vertical line is located at x equals positive 1. You always want to go to where it's crossing that axis, and where at every single point on this line has an x value that was 1. So now letter C is asking if point B was located at negative 4, 5. So let's go ahead and find where negative 4, 5 is. Always label your points after you've drawn them. And it were reflected in the same line. Where would B prime be located? So I forgot to mention before that whenever we are, that the apostrophe means the word prime. So if I didn't mention it before, I want to mention it now, that apostrophe means the word prime. Or our pre-image, or our image has a prime. All right, so I'm going to count. So if we're reflecting across this line, we want to see how far away is B from this vertical line. That is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is what I'm going to count on the other side. Because we want these points to be equidistant away from our line of symmetry. I'm sorry, excuse me, our reflection line. So because they are equidistant away from our reflection line, we would say that B prime is located at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And that would be our answer. We would want to have equidistance away, equal distance away from our line of reflection line. All right, let's go ahead and move on to working with our first set of boxes. There exists some extra special rules when it comes to working with horizontal and vertical lines, as well as reflection lines that are diagonals. So the first lines that we're going to talk about are the vertical and horizontal lines. So how I want you to do this foldable is I would like you guys to please take it and fold it hot dog style. Hot dog style means that it's very, very skinny. So that it's long and skinny. Then I would like you to please fold it in half one more time. After you've folded it, unfold it just once. You will see a crease. We are going to cut just one crease. So once again, I folded it hot dog style. I folded it in half, came back and unfolded just one time and cut up this line. What that's going to do is it's going to create a flip so that we can talk about our information. For this first line, we're going to be talking about a horizontal line. So what I would like you guys to please do is go ahead and draw a quick sketch of a coordinate plane. And we are going to draw a point or a horizontal dashed line on this plane. And I'm going to plot a point just below. And we're going to call it A. A is located at some sort of ordered pair of x, comma, y. If I were to reflect A on the other side, we would call it A prime. But let's think about where its location would be. What would stay the same of the ordered pair? Did it shift to the left or right? No. So if you're reflecting in a horizontal line, the x-coordinate stays the same. The y-coordinate shifted. It'll either shift up or down depending on where A was located originally. So I don't know where it's going to be located. But the key thing that I want you guys to recognize is that the x-coordinate stayed the same. So if you are reflecting in a horizontal line, the x-coordinate stays the same. And the y-coordinate changes. It changes because that y-coordinate or the point was shifted up or down. So the thing that I want you to know is that if you're reflecting in a horizontal line, the x-coordinate stays the same. And that's what I want you to know about horizontal lines. That's where you have y equals a number. The next one is a vertical line. And our vertical line, let's go ahead and draw a coordinate plane down here. And I'm going to draw a vertical dashed line with a point on one side. And we're going to call it letter A. If I were to reflect letter A on the other side, it would be located right here at A prime. My ordered pair for A would start off being XY. Would the X coordinate stay the same this time? No, because we are shifting it to the left or right depending on where A was originally located. So my X coordinate does not stay the same. But what about my Y coordinate? Did this point shift up or down? No, it did not shift up or down. It remains the same. So the thing that I want you guys to know is that the Y coordinate stays the same whenever you are reflecting across a vertical line. So I want you guys to note that this time the X coordinate changes. And that's because there was a shift to the left or to the right, depending on what was going on. There was a reflection to the left or right. But the Y coordinate, it stays the same. And that's because there was no movement up or down. All right, that was for vertical lines. vertical lines, that's where we have ourselves vertical dash lines. And this is at x is equal to a number. When you are ready, please go ahead and paste this into your notebook. The last type of reflection line I need to talk about is diagonals. Diagonals are a little bit different. We are going to create the same exact cutout that we did before, where we're going to fold this hot dog style again to the very best of your ability. And then we're going to fold it in half one more time, but then unfold it. And we're going to cut up the crease. Just one little crease so that we have ourselves tabs. Inside, I would like you guys to please go ahead and draw in a coordinate plane on the top this time. And I would like you to please go ahead and sketch in the diagonal line of y equals x. If I had a point called A and it was located right here, I would need to come up with a point on the other side that was a perpendicular where the line y equals x was a perpendicular bisector on the other side. In order for me to identify what my ordered pairs are, I need to have a rule. And that rule is going to be my coordinates of my pre-image change into the reverse of the ordered pairs for my image. So my coordinates are going to be x, y, changes into y, comma, x. So that is our coordinate rule. The x value becomes the y value, and the y value becomes the x value. This is for if there is a reflection over the line y equals x coordinate rule. And that coordinate rule, once again, was xy changes into y, comma, x. We reverse or switch the ordered pairs. We switch the x and y values. The next one that we have is the diagonal y equals negative x. So if you wouldn't mind sketching a quick graph, quick coordinate plane, and sketch the graph y is equal to negative x. This is the line y equals negative x. And if I were to have a point, we'll call it point A, and I were to reflect it across the line, y equals negative x. My ordered pairs, notice where I had A before. It was at some x, y. And down here, my x values are negative and my y values are negative. And to reflect it across this line, y equals negative x, my x and y values will become positive. So just like reflecting in the line y equals x, we had a reverse of our ordered pairs. Not only do we have a reverse of our ordered pairs, but the signs also become the opposite. So therefore, our ordered pairs, our coordinate rule is going to be x, y, changes into negative y, comma, negative x. And I'm not even going to read it like negative. Instead, I want you to read these negatives as the word opposite sign of. So it's not just a reversal like we had before, but it's literally changing signs. So I don't want you just to say, oh, this one starts off as negative, so when I switch it, it's going to stay negative. No, negatives become positives and positives become negatives whenever you use this rule. This is the rule for a reflection over the line y equals negative x. This is the coordinate rule. When you are ready, go ahead and paste this into your notebook. And use these rules as we complete our examples as well as completing your homework. That is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.